the universe began, light has remained unchanged. Now, man has created a new kind of light with powers and properties unlike anything that existed before. Laser light.
Yo, what's up, guys? And wait, let's wait a little bit for chat to get into here. It's super cold in my room, John. I already told you this a million times.
Yeah. You tell me you have some weather issues on your end.
But yeah, let me make sure that we're good. But how's everyone doing tonight? How's chat doing? How are you doing, John?
Oh, I'm doing pretty good. I'm particularly excited for this session of the 0x2c podcast. I think we both have some really sort of spicy articles to talk about. So
yeah. Oh yeah. Let's do a little recap on. So last podcast we talked about. Well, yeah. So I talked about laser, and you can hack into someone's voice assistant using a laser. So that's super kind of scary. And then John, do you want to say what you talked about?
Yeah. So I talked about how JAXA, which is sort of the equivalent of it's like the Japanese version of NASA. They launched their Hayabusa 2 satellite, which actually went to an asteroid, and it collected samples. And I actually have an interesting follow-up to that, just like a short blurb before we get started with today's content. That the payload has actually successfully landed. It happened this Saturday.
Oh yeah.
And it hit Australia, and they've recovered the payload, which has those asteroid samples, which I think is phenomenal work. And Hayabusa 2, the actual satellite, is now on course for the next asteroid, where it's doing sort of this like a double time operation, which is super cool. So
that's true. Yeah, I saw that on the news that it landed.
Yeah, it's all over
I was
the
like,
news right now.
let's go. We just talked about that like last podcast. I was like, Pog
Yeah.
champ. Julian, thank you for the follow. Very much appreciate the support. Yeah, so I guess we'll go ahead and introduce ourselves again, because last time we didn't record. I didn't click the VOD recording, so that was my bad. But so if you were there, you knew what went down. But I guess I'll do my introduction. So my name is Ryan. Right now I'm a college student, third year, and I'm studying computer engineering. And I do, I guess, on my hobbies, my spare time, I do Brazilian Jiu-Jitsu. That's mostly what I do for active stuff. But yeah, John, go ahead. Take it away.
All right. My name's John. I'm also the same year as Ryan. Ryan has a much better habit. He's a much more physically active person. He's got a good balance between sort of the mind and the body. And I'm sort of like all brains. So I mean, if you look at our the thing on our
About
page, yeah. I work a lot with the sort of quantum computing and sort of blockchain related stuff. So that's sort of my area of expertise. And unfortunately, unlike my good colleague Ryan, I do not get out as much as I should. So
it's been hard though with COVID. I've been having to do Brazilian Jiu-Jitsu with my roommate, and
yeah, it's definitely not easy.
You guys, someone Vacuum Yumu? I probably butchered that. Is your biggest fan, John? We got the real supporter.
We got right. I'm very heartened to hear that. Thank you so much for the kind remark.
Yeah. So basically, this podcast. Okay, you guys probably like, why is your name 0 times 2C, or is it 0x2c? And it's 0x2c, and we basically came up with it from. Pretty much, what were we talking about again, John?
Well, we both work a lot with computers, and hexadecimal is kind of like the universal way you represent data in computers. So we're like, something, and then there's like a phrase like, well, here's my 2 cents. So we're like, our 2 cents. So 0x2c or something like O2c. That's how we sort of came up with it. And Ryan, I think you pointed out like the resemblance to XQC.
Yeah.
What? No relation.
No relation at all. But we just know the famous guy XQC. If you guys know him, he's a really popular Twitch streamer. But basically, in this podcast, what we do is I come to John with 2 or maybe 1 article, 1 juicy article that. And it's completely, John doesn't know what I'm bringing to the table. And likewise, on John's side, he's bringing me 2 or one article that that I had no idea about, and we're basically just going to be talking about sort of what's in those articles, and they're going to be mostly science related technology, the cutting edge in I guess in our world right now, with quantum computing to cybersecurity to computers to I don't know to anything that's technology focused.
Physics, astronomy, biology,
Yeah.
what have it. We're open to all sorts of articles and advancements.
Yes, sir. And yeah, so and how we decide who goes first, John? This time, do you want to flip a coin again, or you just
I
want
think. Well, I have like a die here. I can go ahead and if it's like an even number, it'll be you, and if it's an odd number, it'll be me. How about that? So
Go for it.
I'm
Go for
shaking
it.
this die right now. I'm shaking it off camera right now, and I'm gonna go ahead and. Okay, it's
odd. Okay.
Yeah.
Is that you? Did we call it?
Oh no, I don't think so.
Okay.
Well, you went first last time. I'll just go first this time then.
Okay, go for it.
Oh my goodness. So traditionally, Ryan's always done like a phenomenal job of choosing news articles that are like I think immediately relevant. This may take a little bit of explaining, but Ryan, I think you'll find this particularly interesting. So this comes from Quantum Magazine. It's written by Natalie Wolkover. She's like a senior editor there, and the title is like, okay, physicists nailed down the magic number that shapes the universe. So this is already a sort of a bit of a physics-related article. But the idea goes that there's something called the sort of fine structure constant. It's denoted by the Greek letter alpha, and it's a very, very pervasive and sort of unique value because it specifies how strongly electromagnetic waves affect charged particles. And it's unitless, so unlike the speed of light, which is sort of like meters per second, or I don't know if you sometimes you can go like miles per hour if you wanted to. This has like no units whatsoever. And it has a ratio that is very close to 1/137. So this article was, they interviewed one of the physicists, Eric Cornell, who's a Nobel Prize-winning physicist. He works at the University of Colorado Boulder, as well as the National Institute for Standards Technology. And he notes that many ratios in physics for low-energy matter, such as atoms and molecules, tend to have powers of this ratio. So if you take like 1/137 squared to the third, you'd see something like that. And basically, the news goes that I think it got published just this month, or maybe in last month, that 4 physicists in a laboratory in Paris have reported the most accurate measurement of that constant, or the fine structure constant. Or what's really interesting about this constant is if the constant was any smaller than it is by a hair, life as we know it could not exist. Like, because it also tells you like the strength of electromagnetic interactions. So
Wait,
like
so,
why? Yeah,
so John, so this number, what is it? It defines.
It's the strength of the electromagnetic interaction, or it's like how strongly. Here, let's see if I. So how strongly electromagnetic waves affect charged particles. So essentially, this affects sort of all the matter around us, and it sort of explains why, like when you learn about the atom, the nucleus is like super dense, but the electrons are like, if we blew up the scale of an atom to like human size, there's always the saying like the electrons would be like football fields away from the nucleus. It's because of how small that constant is. It defines a lot of how the matter around us interacts. And if that constant was not 1/137, if that constant was 1/138, life would not exist. Stars could not produce carbon.
Oh, wow.
We would not be here sort of making this podcast and dropping some sort of mad science facts. So
would that constant pretty much go with those constants of like pi, and like those special numbers that we know of in physics and math?
You can think of it that way, but once I sort of finished explaining the recent development with this constant, you'll see why it's such a controversial number. Like the very fact that I'm calling it a constant is kind of controversial, and I'll I know I'm taking up a lot of time here just like talking about but it's integral to understanding why this piece of news is so important. So if we go ahead here, so what happens is the way they measure this constant is you take rubidium atoms, and what you do with those atoms is you supercool them. So you bring them to 0 Kelvin. And once they're brought to 0 Kelvin, you have this laser, it's a specially tuned laser, and you essentially kind of kick the atom. You kick the rubidium atoms, like while they're in this 0 Kelvin state. And as a result, they enter this sort of quantum superposition.
Okay,
so
wait, rubidium atom? What is that? Because I did not take chemistry.
Rubidium is just another sort of element on the periodic table. It has nothing too special with it. The reason why rubidium sometimes gets brought up a lot in the sciences is, I think, and I can't guarantee, I don't know this off the top of my head, is whenever we need, I guess, atoms to play with, rubidium can be vaporized pretty easily. So once it's in this gaseous form, it's a lot easier to kind of interact or play around with for scientists.
Okay.
Rubidium was used for this experiment, but in 2018, another group in Berkeley, here in California, they used cesium atoms. So different atom, but you can still measure what alpha is. And the idea is they, by figuring out how the rubidium atom how much it kicks back, like when I shoot it with a photon, how much the atom kicks back, we can calculate alpha using that value. And once again, alpha is equivalent to the fine structure constant. So this is the most accurately we have measured it. And the actual number, for those that are interested, is 1 over 137.035999206.
Oh, that's good.
That is the most accurately in physics history. Now, here's the kind of interesting thing. The 2018 measurement has there's like a difference between the 2018 to now, and it makes sense because this is more accurate. But the difference is larger than the margin of error, which means that one of them is wrong. One of them is wrong. So there's a bit of
no.
so one of these labs has some kind of error. Oh, okay. Juicy Steak 117 has got it. It is called Sommerfield's constant.
Let's go.
As well. That is an excellent. I chose the name sort of fine structure just because I think that's the name that gets used a lot more often. But yes, you are correct. It is Sommerfeld's constant. And I sort of mentioned this electromagnetic constant, and it's a unitless value, but it comes up a lot in other places in physics. But the other thing the last point I want to mention before I get your opinion on it, Ryan, is that with certain discrepancies of this constant, there have been sort of beliefs, like there's this thing called the Standard Model. And you know how there's a periodic table for atoms, right? Mm-hmm. The Standard Model is for fundamental particles. So you know how an atom has like an electron, a proton, and a neutron. Mm-hmm. And if we go even further, neutrons are made out of quarks. So up and down. So
taking it low.
Yeah, this fundamental, this sort of fundamental model, is the it's sort of like the periodic table for those tinier particles.
So
although
below the build, like what we're taught in school, like the building blocks of matter, lies the quarks.
Way below. We go. I mean, the electron is in there, but it's like the electron's a fundamental particle. And what do I mean by fundamental? Is if I took an electron and I try to like smash it, and I can't break it down any further. It's one whole particle. There's no way I could split it into its other things. So originally, if alpha didn't, or this constant wasn't like where physicists thought it would be, like there's a discrepancy, people theorized there are other particles or other forces that we haven't accounted for. But with this accurate measurement, that kind of throws it out the window. Like we're really certain that the Standard Model, not the fundamental model, the Standard Model is correct to like it holds up. The theory and the experiment kind of match, which is like a really huge pat on the back to the sort of Standard Model.
Wow. So did you look into like the background? Like is Sommerfield's one of the physicists who like was the first one to discover this constant?
That's why his name is associated.
Okay.
I think Sommerfeld was working with sort of Niels Bohr and a couple of other prominent particle physicists at the time, and he sort of came up with a derivation for the constant.
Okay. But how are they gonna decide which one's right now? Since you said that there's one in 2018 that has, different value than the one in 2020.
So they're going to try and repeat. They're going to do a repeat essentially. So they sort of this sort of group in Paris hit up the other group, and they're like, hey, we need to we should probably sort of rerun this, because the trait of like any good experiment is you can repeat it and get the same value again. So
okay. And what was this? When did they in what month was it?
You mean what month like this experiment took place?
Yeah.
I think it was like, well, okay, they started work in February, and they've been repeatedly conducting this experiment to try and like reduce the error as much as possible. Because when you're measuring something this precisely, the smallest possible deviation can throw you off. So they have to like do a bunch of work here. But it started in February, and I think they published last month. Maybe around November. I think around November. It's in Nature. For those of you that are like sort of huge, like who know a lot more than this, if you can read that research paper, mad respect to you.
So you can find this in Nature. So where else can you find this in? Not just like from experiments, but where else in Nature can you find this constant?
Oh, I mean like Nature as in the name of the scientific journal.
Oh, okay. I was like, whoa.
No, but it is found in Nature. I didn't look too much into like other ways it can be found, but I think another example that I can give is nuclear fission. So nuclear fission is like a nucleus gets super big and then it wants to split up.
That's
and
right.
Release energy. So one of the ways this can get started is in nature, we've seen this before. There's something called a natural nuclear fission reactor, and it's where these uranium deposits in the Earth can naturally, like they spontaneously have a self-sustaining chain reaction, like the nuclear reactors that we build artificially.
Wow.
And the idea is, for that kind of reaction to happen, a neutron, which is bigger than a proton, it has to like absorb an electron, or no, maybe it's the other way around. Maybe it's okay.
50-50.
But I'm kind of embarrassed. I can't remember. But basically, the nucleus absorbs an electron, and fission starts to take place. The nucleus gets unstable, and it starts the chain reaction. But because alpha defines interactions in the electromagnetic field with charged particles, if alpha had changed, that reaction might have turned out differently. So that's why that brings me back to what I was telling you earlier, with the constant being non-constant. Like for the longest time, physicists have fought over how constant is alpha, and for the most part, physicists believe that alpha has been constant in the universe's history, but there have been some like satellites that monitor certain star formations, quasars, which produce sort of this very strong radio wave, these radio wave pulses. And what they found is there may be a chance that in certain parts of our universe, alpha is different. Now, why is that scary? Why does that matter? Because to generate alpha is actually a ratio between the charge of an electron, the speed of light, and Planck's constant.
Oh,
so
man.
What that means is if alpha is different, that means one of those is not constant.
Yeah.
Which is super cool. Like, it's mind-blowing. That means that, like, maybe in a different part of the universe, the laws of physics are not as universal as we say. But...
So you said quasars. I have heard of pulsars. Are they similar in that regard?
I think they are similar. I don't know the distinction off the top of my head, unfortunately, other than I think like they have like strong, very strong radio wave or electromagnetic.
Yeah, and pulses. I think I was reading somewhere, and pulsars have like 100 million times the strength of our magnetic field of Earth. It's 100 million times stronger than of Earth.
Holy smokes!
And
I better not.
I know, right? What should we call it? And speaking about nuclear fission, as much as I know, if we are able to achieve that in like a stable form, wouldn't that revolutionize batteries, just energy in general? So
I made a little hiccup there when I was talking. I meant fission, nuclear fission.
Oh, okay,
so fission is like normal sort of radioactive decay. Fusion is like what happens in stars. And you're right. If we could achieve fusion, that'd be revolutionary. Sort of clean energy. You only need hydrogen. Very safe too. But the biggest problem with nuclear fusion is it takes the amount of energy required to start fusion is insane. It's nuts. It's nowhere near what we can sort of pull off. So everything that you hear, like we're building these fusion reactors, they're prototypes. So they're not really self-sustaining. We turn them on for maybe a fraction of a second, and then it sort of like it dies by itself. GC said, yeah, I've played Outer Worlds before. I know about that.
Oh, is Outer Worlds like a video game? It's like it's a simulation game.
I guess it has some. Oh, Wilds. Okay, Outer Wilds. I don't know that game.
Yeah, I don't know either.
I thought it was Worlds. My bad.
Outer Worlds.
Yeah. I mean, now you've got
Outer Wilds. Oh, interesting.
Now you've got Ryan interested.
It's an action-adventure game developed by Mobius Digital.
That is
interesting.
Yeah, that's sort of my I thought that was super interesting. Like this constant has been measured to such a high level of precision, and just how important that constant is, and the fact that there is a chance that this constant is not constant. Maybe there's a part of the universe that doesn't obey it.
If it's related to if it's somehow, like you said, it's like the formula you said, the ratio between the other constants.
Yeah.
And if it were to change, then that would, change the whole entire game.
Right. That means one of those constants has to be one of the constants in the ratio has to be non-constant, and we don't know which one it is, and we're pretty scared. But to give you an idea, though, the difference in that constant is super. Like we've bounded the possible it's like 0.00003%, or maybe even less. I kind of skimmed that number from one of the articles I was reading. It might be even smaller than that. But
wow.
So
I don't know how physicists do this stuff, man. That's why I'm not a physicist.
Oh, same, bro. I sorely lack the sort of mathematical rigor.
I remember in one of my physics, 9C, was it 9C? I think it was 9C, when we learned about electromagnetic waves and the magnetic field and how they interact, all the charges, how they all react to each other. One of the TAs, he was researching and he was doing his PhD in black holes. So I stayed after his lab one day. I think it was during like the fire or something. Like where lab wasn't mandatory, but I still went because I'm a freaking nerd. So I was like, I gotta get my points, bro. Still gotta grind. And then he was talking about black hole, and he was like, hey, you can ask me anything. So I asked him like a bunch of these like common black hole, questions, and I don't remember what questions were, but it was super interesting to hear about like what he studies. And like, the boy was pulling out like gradients on the board, and he was trying to explain to me in math. I was like, bro, how am I going to understand this stuff?
Physics is, it's definitely like, to those who can understand it and who work in it, like I applaud them. But
it's amazing.
And GC Steak here says, this is why I'm just a pure math major, since I'm trying to have fun in my life.
Man, even math though.
They go
tough.
Hardcore, man.
They go hard, man.
Hardcore.
Number theory and all that.
Oh yeah.
Stats. Would you consider? Yeah, stats is, I would say, branch off math, right?
Absolutely.
You just focus on that.
It's sort of in the umbrella of mathematics, and like for literally all the sciences, if you want to figure out if your data is like significant or not, you got to use statistics. Like in any field of science, I would argue, like you need to understand like what a standard deviation is.
Yeah.
How to perform some preliminary statistical analysis, how to find anomalies. You need statistics for any field of science, I would argue.
True. It's very true. Juicy Steak says just count and it's easy.
Yeah.
For real. Man, honestly though, if I were to switch majors, I would totally switch into math. Like, for sure.
Well, I've seen you with numbers.
If I could switch, I would minor. If I could redo something like last year, I would start minoring in math, because I feel like math is such a fundamental thing to know, or like thing to have like under your belt, for my personal opinion. Because I don't know. I find it really fun too, I guess. Sort of biased opinion.
Yeah,
that's a biased opinion.
That's all you. But I think math is like, even if if we stop talking about the difficulty and the applications, just to think of like, the history of math. Like math doesn't really sort of exist like it's just we have these abstractions. We started with like the number 1, the number 2, and then a lot of stuff, right? And then we counting, and then we had like addition, subtraction, division, and then you had algebra, calculus. Like the number of abstractions and useful tools we keep finding for math is simply it's incredibly beautiful and super cool at the same time. Just like how much these abstractions can apply to the physical world.
Yeah.
And how science and math, they pretty much go hand in hand. I mean, you got to know, enough about one to do the other. So.
Yeah, it's just how you can like describe a field, a vector field, or an electromagnetic field using math, right?
Yeah.
So
yeah,
it's a fundamental concept. That's but want to go ahead and move on to another article, John?
Yeah. I mean, let's go to yours.
All
I
right.
mean, I think I've sort of sandblasted all this physics stuff. I'm dying to hear what you got in store. So.
All right. That's it. Okay, let's go for it. Okay. So basically, mine is probably not about physics. Oh, okay. It's astronomy. But let's go. So this article, titled 12 times the Arecibo Telescope helped us figure out the universe. And so recently, like literally 4 days ago, on December 4th, 2020, the Arecibo Telescope like demolished itself. It broke. One of the telescope, a part of it fell onto itself, and it just broke. It was already having failures like a couple months beforehand. So this is sort of recent news, especially to the history of what the Arecibo has done for us, figuring out things in the universe. And so I only picked 7 out of the 12 because 12 is quite a lot, and some of them were kind of. It was like, oh, okay, cool. I'm gonna pick these 7 because they're kind of cool. So I'm not gonna go over the entire 12, but I'll go ahead and John, you should link your article if you have any citations in the chat. I'll link mine in a little bit. But let me give you some, I guess, background on the Arecibo Observatory. Have you heard of it before, John? This telescope?
I have. I know that wasn't Arecibo part of SETI, the Search for Extraterrestrial Intelligence?
Yes, sir. Yes, sir.
Okay, so that's where I know it from.
Yeah. So basically, it's found in Arecibo, Puerto Rico, and hence the Arecibo Telescope. And should I say with it like a Hispanic, Arecibo, Puerto Rico? All right.
I mean, you speak Spanish, right?
That's true. Yeah, I do speak Spanish.
Okay, then I say you go with the proper pronunciation.
And it's pretty similar to English, but okay. It's owned by the USNSF, which is the United States National Science Foundation. And basically, I'll give you some background on this telescope. It's 1,000 feet in diameter, and it's basically just a dish that was built into a natural sinkhole, and it just has a cable mounts, a receiver, several radar transmitters for sending signals. But it's just basically a big dish telescope. I'm not sure if chat has seen one of those, but so it was completed in 1963. So it's about. Well, it is 57 years old, and it rest in peace. It got demolished a couple 4 days ago.
I saw the video. Like,
you saw it?
A cable snapped.
Yeah.
Right? And the whole thing just fell in.
Yep.
Like if this was the dish, if this is the dish, and then there's the actual receiver where the radio waves get reflected in.
That's
that
right.
thing just sort of fell, and it just yanked everything down with it. So it was.
Oh no, we're having some technical difficulties. 1 second.
Uh-oh.
Can you guys see it now? Is it better now?
Okay. Oh, that's it. Looks like
works.
it's back
Okay.
on.
I must have done something. Okay. So yeah, and before they even can demolish it, it was already broken. So the first thing we'll start off is that I guess in 1992, this telescope found the first ever extrasolar planets, with 2 planets orbiting a pulsar. And so what is a pulsar? For those that are not too familiar with pulsars, I know John brought up quasars, right?
Yeah.
From the previous one. But so a pulsar is a highly magnetized rotating compact star that emit beams of electromagnetic radiation. And sort of, I guess, to visualize it, it's like, I don't know, it's like a like a little ball, a little star, a little planet, and then you have like it spins super fast. So they have a couple of names for them. This one in particular is known as I guess they're all known as millisecond pulsars. Not all of them, but this one in particular, because it spins about 100 times per second. So that's pretty fast. And I guess what makes these pulsars so special is that they're useful for astronomers in particular observations in the binary neutron star system, and they were used to indirectly confirm the existence of gravitational radiation. And so gravitational radiation is sort of what basically Einstein was talking about with warps in space, in space and time.
A large enough gravitational body will kind of warp the sort of fabric of space-time.
Right.
Okay.
Right. Exactly. That's a perfect explanation. Yeah. So warping. It's basically, I guess, good analogy is when you have when you have your bed sheet on the bed. I'm pretty sure you guys may have heard this analogy, but you have your bed sheet, and then you place like a sphere on it, and it bends it. Sort of bends into the bed. And I guess that's like sort of the analogy of like warping time and space. But so yeah, pulsars are just spherical compact objects, and a little fun fact, they're about the size of a large city, but contain more mass than the sun. So these are super dense, objects in space. And also another fun fact is that Jocelyn Bell, who's a woman, she was the first to discover the first ever pulsar.
Wow.
So
okay.
That's
not through the Arecibo. Like we knew about these things before radio telescopes, right?
That's right. So it was with this telescope she discovered the first pulsar. So
wow. So you said that they used it to confirm the first sort of planets that exist outside our solar system, right?
Yeah.
Oh wow. Okay. So how what were the sort of, do you know the exact sort of mechanics? I have like a hunch about how they might have done that, or the mechanics, but
how they transmitted those waves?
Yeah, or like not the way, but like how they use the telescope to figure out like, there are planets that are not in the solar system.
You want to explain that? What your hunch is? Because I didn't look into that.
So I think usually with any sort of extrasolar planets, barring this example, I think it's nicer to work in sort of the optical realm. So if I'm looking at a distant star, far, far away, and I can't really make out that really tiny planet, what happens is if a planet is orbiting a star, the brightness of the star will dim down, and then it brightens up again, and it dims and it brightens, and it dims and we, from that sort of behavior, we can kind of infer there's some body that travels in front of the star and Earth, and then we can kind of determine, okay, how big is this? What's the how far often it orbits? So I think with that radio telescope, what you're talking about is the quasar has radiation coming out of it.
The pulsar.
The pulsar, excuse me. But when the planet comes in front of the pulsar, it kind of blocks off the traditional amount of radiation. So the telescope, our radio telescope, is can kind of monitor that behavior, or it kind of figures out like, there's something that is orbiting this pulsar. I think that's probably how they pulled it off. But you mentioned it was a binary system, right? So that means it's two things like orbiting each other. So that my hunch might not be correct, but that's traditionally how people have found extrasolar planets.
Okay. Yeah, I would have to look that up in specific details, but that's more than I would know. Hey, what's up, Matt D? All right. And so the second thing from this Arecibo, what we've gained from it, was the origins of water, ice on Mercury. So, I mean, we always hear about Mars, right? But Mercury has shown some extremely reflective material radiating from the surface, and we've interpreted it to be as ice. And this was found in 1991. But yeah, why are we so fixated on Mars? Is it because we're closer to Mars, or like it's farther away from the sun? What do you think?
I think the whole thing behind Mars, right, is we have this kind of dream that it's kind of this. If humans can go there and we can establish like a base, and it's kind of like the next step in exploration. Because if you think about it, Venus is pretty much inhospitable. it has like the hottest temperatures known, like sort of underneath its atmosphere. And Mercury is that's even closer to the sun. It's also very sort of inhospitable.
That's true.
Like on Mars, there's still a chance we can actually walk on the surface of Mars.
That's
Whereas
true.
I don't know about Mercury or
Mercury
Venus.
is really close to the sun, huh?
Yeah. Not to mention that Venus ain't got nothing on Sacramento in the. but like Venus rains sulfuric acid.
Ooh.
Venus rains like so that stuff like you got to build spacesuits and you know it's
protection for that.
Yeah, I mean
Right.
it's nuts. Like I don't think that's sustainable at all. So Mars is kind of our best bet here. And I think one last thing, and I'll let you keep going. I'm sorry, I keep.
No. Go. No, this is perfect. I think honestly, this article is like let's just branch off into like what we know about it.
Yeah, absolutely. But Mars has these sort of polar ice caps, which could potentially. I think they have. Although it's like I've heard there's like frozen carbon dioxide in there. You can have like frozen water there as well. So if we establish like a base and we're like, oh, Ryan, I need some water, then we can just sort of go up north or go south, and you can get water from there. So that might be promising for sort of future space exploration or colonization even.
Oh, and did you know Venus is like I think it's the planet of love or something like that? Like it's like
Yeah, it's named after the goddess.
yeah. Shout out
yeah.
Venus. Okay. And the third. Okay, so this is the third one from the article. It's the Arecibo message. And are you familiar with this, John? The message that's been sent that we sent out for. Okay, yeah. So the Arecibo involved in the search for extraterrestrial intelligence, or the SETI project. We basically sent out this message, which was carrying basic info about Earth and humanity. There's a nice YouTube video on this, but the message basically contained our information about like our number system. Well, like from 1 to 10, the atomic numbers of the chemical elements that make up our DNA. It had the dimensions of the average human, which is pretty funny. I think they show you on this article. It sort of looks like a Minecraft character, like a video game character. We're in the simulation. But anyways, it showed the graphic of our solar system and the graphic of the Arecibo Telescope. So it's pretty cool stuff. And a side note, Stephen Hawking and this Russian billionaire Yuri Milner, they announced a well-funded effort called Breakthrough Listen, which was basically another, I guess, organization just like Search for Extraterrestrial Intelligence, but Stephen Hawking and this Russian billionaire had their own thing that they funded called the Breakthrough Listen. So
they're also like trying to search for extraterrestrial life.
Yeah. So I didn't dive too deep into that because that was like branching up to like a lot of things. Like holy, but that's a cool segue if the chat wants to know more about that.
Well, I thought that's kind of interesting you bring, because I think Stephen Hawking also, like, I think he was a strong proponent for realizing, like, he sort of put the point on the table, and he said, hey, although, like, we might think that extraterrestrial intelligence is friendly, there's an equally likely chance it's hostile. Mm-hmm. So how would we know, like, if we're broadcasting to the entire universe, like, hey, you know, we're humans, we have this much technology, you know, like how do we know that this doesn't get picked up by sort of a hostile intelligence that maybe doesn't want, you know, to coexist with humans? Maybe they have some sort of urge to, you know, extinguish. We don't know. We don't know. So there's a bit of risk that goes with, you know.
Right. I mean, that's sort of like setting out your IP address out in the internet.
Yeah,
and then seeing who responds.
There you go.
It's that's super scary. Now that I think about it, like, what the hell?
Yeah. So, you know, I mean, I think it was Hawking, or it was another physicist who sort of pointed out, like, are you sure this is a good idea? You know, you want to tell the entire universe.
Well, we need to start building those lasers that shoot those asteroids ASAP. Otherwise, we won't make it.
Oh man.
Okay, and so continue on. There's the fourth one, which is finding dark matter galaxies. So in 2006, astronomers found a mysterious cloud of hydrogen, which was 50 million light years from Earth, and they called it Virgo HI, which I'm pretty sure stands for like some periodic stuff. 21.
Okay.
Yeah, so I thought that was interesting. And then the fifth one, understanding the weird signal, and it was basically just a signal that we got that people thought, oh, is this extraterrestrial? But it was just really an interference from a nearby signal. But there's another occasion in Ohio State University where there was a signal called the WOW, and
Oh, okay.
yeah, and then they say the signal came from the constellation Sagittarius. So, and yeah, it said wow. So I wonder what they're trying to tell us with that.
Wait, you said wow.
Like WOW exclamation point wow. Like wow.
Wait, like the data said wow, or like the. Wait, what do you? Okay, I still don't.
The data, the signal, like whatever they picked up from Ohio State University with their telescope, they came up with like this.
It was an anomaly, right? Like the actual, like I thought it was because someone wrote like "wow" exclamation mark on like the actual data, right? They circled the signal spike and they're like "wow," and then exclamation.
Yeah. No, that's what's from. Yeah.
Okay.
Okay.
I mean, we don't know. Do we know if that's interference or was that like an actual unexplained astronomical phenomenon that we don't know?
I think what I remember is that they don't know the WOW one.
Okay.
The weird one was interference.
Okay.
Yeah. Oh yeah, and it was anomaly. Yeah, thank you, John. I had that in my notes.
In fact, speaking of anomalies, I remember there's an incident. I don't know where this happened, but I know this is factual. There was a radio telescope, and they kept picking up some really weird interference. And for the life of them, they couldn't figure out where it's from. Can you guess what like the culprit was, Ryan?
A microwave?
Yeah. No,
Oh.
it was somewhere in the building. They had a microwave, and the microwave like leaked some of the EM radiation. So the telescope picked it up. And they're like, "What the heck are these readings?" And it's like I'm like, that's nuts, thinking that your microwave is like contributing to false results.
Someone's just heating up their hot pocket, and then they're throwing off the entire SETA project. They're like, "Holy crap, we found someone! We're onto something." Yeah, that's kind of a tease. So the sixth one was the Arecibo Telescope also found the most metal-poor galaxy in the known universe. So in 2016, astronomers found this galaxy with the lowest known, metal, which
like you mean like amount of metals in it?
Yeah. So like basically, what they're saying is that it can give us a glimpse into the early days of the galaxy. So, before we had any metals, I guess. It shows the early days. And what's interesting about this is that if you think about it, if our galaxy didn't have any silicon or anything, or like mostly silicon, we wouldn't have, computer. Maybe we would have used like copper or something, but.
Well, maybe not germanium. Because
germanium.
We need silicon because it's a semiconductor, and semiconductors are fundamental to transistors. So I would imagine that if we had no silicon, we would find another substitute, which would be germanium, because it's in that kind of diagonal band of semiconductors on the periodic table.
Gotcha.
Wow, interesting. A galaxy with like the least amount of metal in it.
Yeah. Which it's sort of, it's like I guess they say it's a glimpse into the early days of our galaxy, and
I can understand where that comes from, like because like in the very early days of the universe, the most abundant element, I think like to this day it's still the most abundant, is hydrogen. But then with stars, they perform nuclear fusion, right? So hydrogen, kind of fuses into these other, you can get lithium and carbon and oxygen, nitrogen, and you get to heavier and heavier elements. So maybe when you said like it's a glimpse into our galaxy, maybe that galaxy is like super young. Like it has not it doesn't have as many sort of dead stars lying around that sort of crank out these heavier metals. Is there a name for this galaxy? Like if chat wanted to figure out or wanted to look into this?
I'll link to the article because I don't think I wrote it down, but I don't know if there is a name for it.
Okay, yeah,
but I would assume there would be, if it's like this special.
Bro, you've seen how astronomers categorize, like, oh, this is star something, Pegasi 51.
Yeah,
like,
BX.
There's like Greek names or like remember I was telling you about the asteroid, the Hayabusa 2 asteroid? It was like something 162. Like it had this ridiculously long numbers.
Yeah, no, I mean, Elon Musk named his kid a freaking galaxy. I swear.
Oh.
AE, what is it? AE12, something like that.
Yeah, XAE. It's not even like someone figured out it was like Kyle. I think it was like a speculation on Twitter that it was Kyle, but it's like Archangel 11 something is like the code name for an airplane. I'm like, this is just a terrible name. I would not name my kid that. I feel bad for that kid.
Yeah.
Like
I mean, I imagine all the subs are gonna be like, what? Or even the teachers.
yeah, I mean, his name, he's been memed like so often on the internet. Like imagine growing up.
I know, growing up.
Dad's gonna be like, oh hey son, like by the way, you were memed like all over the internet. I'd be like, yo, come on.
I wonder how his dad calls him. Do you think Elon calls him by his first name or his last name?
I think later on they changed it to like something more reasonable. I don't think that was like a permanent thing because like there was an interviewer who asked like, "Oh, how's XAE12?" And then Musk was like, "What? What do you ask?" And then Musk, the reporter said it again, and Musk was like, "Oh, you mean my son?" And like, and then even Musk himself said it sounded like a password. So,
he's like, "Wait a minute, that's my password. Why are you saying my password on live TV?" That's funny.
I don't know, man. I don't know. I have reservations against like why would you name your kid that? Come on.
That kid is, dude. But imagine being that kid. His expectations. Do you think in life it's gonna be trying to see if he can live up to his dad's name?
I don't know. I mean,
that's scary,
Musk
dude.
has a lot of children. Like if you look at the official number, like, he's got a lot of kids under him, and I don't think he's that like. I feel like
he's pretty
he
chill.
wouldn't be the kind of guy, who wouldn't be like you must build a company as well, and carry. I don't think he's that.
Carry
kind
on
of
the
guy.
torch.
Yeah, I don't think he's that kind of guy. But why don't we loop back to the article? Let's,
So the seventh one is the last one is the distant galaxies. So these distant galaxies that could hold ingredients for life. So this sort of branches off the previous one. Is in 2008, Arecibo detected the molecules Okay, I'm probably gonna mess up on these pronunciations. But methanamine and hydrogen cyanide, which are two ingredients that build life-forming amino acids, and they found in a galaxy 250 million light years away, which I converted to miles, which is like 1.5 times 10 to the 15th miles away.
Oh man!
So it's kind of far. But hey,
Yeah,
we sort of know that there are galaxies out there that do have, I guess, the ingredients to form life, which is pretty interesting.
Yeah, I mean we've seen exoplanets as well. I think like they're promising, like they could potentially have like liquid water on their surface, or like we see all this evidence in the universe, like the ingredients for life are out there. But interestingly enough, we have yet to kind of see something like from Star Trek, like bump into like some Klingons or Romulans or whatever. It's unfortunately, well, maybe fortunately, considering how primitive we are compared to the aliens, we haven't sort of bumped into that yet. And
actually, from the Pentagon leaked videos, I would say there's some weird stuff going on in those videos. If chat knows what I'm talking about, have you seen them, John? The aircraft that's like defying gravity.
Oh, all those UFO videos.
Yeah,
those
ones go.
Project Blue Book, where like I think the government was trying to like categorize all these UFO instances. I mean, like I kind of like the playful theory, and I know there's no merit to this theory whatsoever, that these UFOs are actually us, but we're kind of going back in time to,
whoa.
I don't know, like,
Yo, no, dude, my brain just got like, you just blowing my brain away, dude.
Yeah, I'm just, it could very well be, I don't know, but, wow, okay, so we have hydrogen cyanide, and did you mean like methanamine?
There it is, methanamine.
Okay.
Just meth. They have meth there, bro.
I mean, have you read or like do you know about the sci-fi series Dune?
Dune?
Dune,
like
yeah,
Dune?
Yeah, Dune.
I think no, I haven't. I don't think I've watched it, but I've only heard of it.
If you really wanted to kind of sum up what it's about, it's like there's like this the spice melange, which is essentially like overpowered space crack that like specialized, that like people use to kind of bend space time and but like if you're interested in like sci-fi, like the world building in Dune is absolutely phenomenal. But I mean, in my brain, I associate that spice with like crack pretty much. I mean, because people can like develop
space crack.
Yeah, but it gives you like these like sort of mind enhancing abilities and all this stuff. So
what if there is like a dust out there that you can crush and then you just take it and then you're able to like be a butterfly in the galaxy? That would be
maybe. I mean,
it's funny because that reminds me of I had a professor, a math professor, and he told me that he was solving. Who was it? It was some type of series he was solving, and it was like one of those. If you solve it, I think there's cash involved. I forgot.
Oh, was it like one of the Millennium problems? Like I know there's like a number of math problems that are like unsolved, or like if you could solve them, like there's a huge reward or something. But
yeah, I'm just trying to remember. I can't remember the name of that series, but he solved he said he solved a part of it. I just forget like the name. But what he said, he was so obsessed with the problem, he fasted. So he went into fasting for like, he said 40 days. So 40 days and 40 nights, like Jesus. So my boy was transforming he was transcending into Jesus. And then he was saying that he wouldn't eat. He wouldn't even drink water, he said. And he would literally wake up, do the problem. And then he wouldn't even sleep. That's what he said. He wouldn't sleep. His wife was getting really worried because he wasn't eating either. So he's telling me at the dinner table, his wife would tell him that he would hold the spoon and he wouldn't eat. And then he'd go back to solving the problem. And he reached this point of like, I guess in meditation you call it transcending. He said he was like a bird flying through the galaxy. I remember that word for word because I was like, holy dude, he's on some other level of like obsession with like a problem, which I admire so much because it's like one day I want that's like me personally. One day I would love to be obsessed with a problem that I sort of reached that like point. I don't know. But but the thing he told me is like, hey, you got to be careful because some people don't make it. I was like, whoa, what do you mean by that? And then he's like, yeah, some people, don't make it. I was like, whoa, dude. And he was a Japanese professor, Professor Milase, well-known, Motohiko Milase, well-known professor in Davis. Yeah.
Okay.
And I was with Sarika. Shout out Sarika. But yeah, that was interesting talk.
Yeah, it's pretty interesting. Are we still planning on going just for an hour, or do you want to go like
holy crap, it's
hour 30? Yeah.
Do you want to go over your second article?
My second article is one of like it's probably like gonna get you. It's like I keep saying sandblast because I always have like these are like some like niche articles and I always have like a bunch of context for them. But do you have a second article you want to go over?
Yeah. So this one I guess is the Apple and Google are building, and also Facebook, I heard, they're building a coronavirus tracking system into iOS and Android. And so a lot of people are confused because they said they think that they're creating an app for everyone to download, but that's not the case. They're just building the API or the application programming interface for that, for healthcare to use that and to create the app. So they're not creating the app. They're only providing the tool. So basically, this article is just talking about how they're implementing it. So, I guess I mean, do you have anything you want to say before I dive in?
Well, I know like the traditional history, like a lot of these efforts to implement sort of digital tracking systems have always been mired in a lot of concern because a lot of people, are very conscious of or at least like the especially under these sort of pandemic times, people have become immensely more sort of sensitive to their privacy. Because we work from our computers and we do everything digitally or remotely now. So we have to have more faith that, these computers aren't spying on us or that they can be compromised. And with any digital tracking system, even, for the virus, people worry, like, can that data be tied to me? And even though there are all these promises, like some protocols say, like, we use hashing or some cryptographic methods to sort of prevent tracking from happening, like getting it tied to you. It's just a very hot topic. It is a hot topic. Yeah. So why don't you? So we're planning on going for that extra 30 minutes. I mean, I think we still got 3 viewers here. I wonder if I'm one of those viewers though, because I'm not logged in right now. I'm using the.
You very well could be.
Yeah, so I might be one of them.
It's up to chat. I don't know. Does chat have any input on anything we've said so far?
Yeah.
We could just end it off here. It's been 1 hour.
Yeah, I think we might, because I see like 3 people here. I think it might be best if we. No, I'm listening. Oh, okay. So Juicy
nice.
Steak is
Thanks,
Juicy
Juicy.
Steak is in it for the long haul. Thank you so much for sticking around. We appreciate
Respect. Yeah. So y'all do whatever's nice. It's nice background noise. True.
it. That's good.
I honestly just spend like the last 10 minutes with the viewers.
Yeah,
Or like 5 minutes, just say what's up. Are you working on homework right now, Juicy? I know. Well, I don't know if you're in college or anything, but finals week is for both John and I soon.
Coming up.
So that's gonna be pretty. Oof.
Oh, I just thought of something. You were talking about those pulsars, right? I have a funny little story. I don't know. Maybe it's like a sort of an innocent childhood story. But I used to be like super into astronomy when I was in elementary school, and I wanted to try and build a radio telescope. And this was like I was like, I don't know. I was like fifth grade.
Really, dude? That's crazy.
No, but it's stupid. It's so stupid because all I knew was like, oh, these radio telescopes use radio waves. So if I could like receive and decode the waves, right? I was like, oh, I could build one of these. And it was, I wish I had a picture to show you, Ryan, but it was the dumbest thing. It was this rinky-dink like telescope, like one of those like $50 cheapo ones. And I duct taped like the TV antenna, like the I duct taped it to the end of the telescope, and then I think I broke like a $5 radio.
Oh my gosh!
And I was like, let me try and like put this little thing together. And of course it didn't work. Of course, like I didn't get anything useful. But I did it for like a elementary school science fair project. I'm like, can you detect? And I'm like, hell no, you can't detect anything with this thing.
You should be like, bro, at your science fair, you'd be like, oh yeah, I'm getting something, guys. I'm getting something.
But it didn't like, because I thought it was super cool. Like I could pretend to be a scientist. I could pretend to be an engineer. And I think that's why, like, I'm studying what I am now in college.
That's interesting.
But, oh yeah, I saw. I think Juicy has another question here.
You want to read it, John?
Yeah. Let's see. What's the inspiration on the podcast title? Obviously, it's hexadecimal, but wondering if it's a reference or something that I'm missing. Okay, so you are correct. It is hexadecimal. The inspiration is kind of Ryan and I both work a lot with computers, and the thing is, I've heard the phrase before, sort of like our 2 cents. And originally, I think we wanted to use 0xFF, just like a random hexadecimal number. But then I think we realized like FF is used. Like we went on Google, there's like another IT podcast that uses 0xFF. Mm-hmm. So we had to choose like what's a neat kind of hexadecimal identifier. And I came up with the phrase like, well, like here's my 2 cents. So I'm like, oh, if it's Ryan and I doing this podcast, it's like our 2 cents on like the latest and greatest in science and tech. So 0x2c. And I guess it kind of helps. Ryan, you mentioned there's some resemblance to XQC. Yeah,
some relevance to XQC. So
even though we don't play games and we don't have difficulty identifying animals. I think you've seen some of his clips. Like,
I'm dead.
He called like a cheetah. I think like he saw the cheetah and he saw it for like 10 seconds and then he said, Cheeto.
Cheetos. I'm pretty sure he was thinking of hot Cheetos, I'm assuming, and that's why he probably said, but still though, like
there was a donkey and he called it a dog. Like, oh, what's wrong with this dog? And I'm like, oh man.
Oh no. I mean, it's crazy how much viewership he gets too, but anyways.
Well, yeah, I mean, he's a popular streamer, although he does have some controversy. Like he got the whole stream sniping incident. That's a big no-no for competitive games.
That's true. Yep. But yeah, what were we talking about before? Oh, okay. Well, one thing I wanted to say is, okay, at age 5, John, that's first grade, right?
No, not I said 5th grade, dude.
Oh, okay. I was like age 5.
No. I'm definitely not that, like, I'm not that brilliant, bro.
I was
Absolutely
like,
not.
dang.
No. It was at like 5th. It was so dumb though. Like if you saw the setup, you would laugh your butt off. It's this like VHS antenna, and then with the telescope. And I'm like, oh, let me see if I can aim it towards something. And I had it wired. Like this is so dumb. Like I mean, to give you an idea of how dumb I was back then, I remember like there was a portable TV set. I didn't know what the flyback transformer was. And that's like thousands of volts to like get the cathode ray tube. So I'm kind of like poking this TV while it's still like powered up, and I shock myself.
Oh.
But I thought it was super cool. I was trying to build an oscilloscope. I was trying to build it like with the old TV.
Yo.
Like there's a really easy way to do that, but yeah, I was like from that point on, I was like, John, you gotta learn. You gotta actually learn how electronics work. You can't stick your screwdriver in everything. So I'm like,
gotta reverse engineer.
I guess so.
Yeah. Honestly, I feel like you can learn way more by taking things apart and then doing the reverse engineering. Like that's why I hear a lot of like these guys that are in electrical engineering. They're like, yeah, I learned this because I took it apart and then I built it back up. So it's
definitely like I used to go to this like recycling center. I get like a lot of these old PCs and I take them apart, and that's how I learned like most of what I know about computers. Like I take them apart, put them back together.
Wow.
I'd build like Frankenstein PCs. So I'd get like 3 different machines that were broke, and I'd be like, this works and that works, and I'll put it in one machine and it works. But
dang. Yeah, I remember in 5th grade, I was just in those after school programs, and then I'd go home, do my homework, and I'd go play. What do I do? I'd play Call of Duty.
I mean, that's a healthy childhood, bro. That's a healthy childhood.
Yeah.
I gamed like during. I had a brief stint in gaming in like junior high, and then I just lost interest because I'm like, I can rack up like points in these games, or I can like learn something that's like physically applicable.
I never had that click until later on, until like literally I would say senior high school. I think it's because the people you surround yourself with influence like a variety of things too.
Oh, definitely. But I think
it didn't help. My ex was in she was in the nerdy group, I guess you would say, in high school. So I could never hang out with them, even if I wanted to. It just felt weird.
Oh, Ryan, you gotta lean like close to your mic. It cuts out a little.
Okay, sorry.
Yeah, there you go. It's all good. It's all good, bro.
But yeah. I mean, what else? I hope chat's doing well.
I think we've hit the hour mark, bro.
Yep. So I think we're going to go ahead and just end it here, guys. I hope you guys enjoyed this podcast. I'm gonna download it, upload it to YouTube. So on our About page, we have a YouTube link. So please go ahead and check it out, subscribe. I think we'll end it off there. So thank you, Juicy Steak. Thank you, Matt. Thank you, Reanimated Nat, for the support. Thank you, Vacuumu and Yellowberry HN. You guys all that commented.
And we got a follower as well.
Yeah, and Julian. Yeah.
Thank you so much.
Thank you guys. Yep. We got a new follower.
Oh really?
Yeah. I can't. Oh, who is it? I can't.
Oh, we gotta.
I gotta pull it up. Give us special shout out.
Let me see if I can refresh my page. I really want to give a shout out to this person. Let's see if I can refresh my page here.
Juicy Steak.
Thank you, Juicy. Nice. Okay, nice.
It didn't I couldn't see, it was small for me, but okay, cool. Yeah, thank you, Juicy. Much love. We'll be streaming again next week on Sunday. So yeah, that's definitely pretty much all we have, I guess. So thank you guys again. Hope you guys have a good night, and good luck on your guys' finals, on your guys' future endeavors. We'll see you guys next week. Bye.
Peace out.